Assalamu alaikum and welcome to all viewers. Whenever an object is raised to some height to fall, the object gains potential energy, and once that object leaves to fall free, it loses potential energy and gains kinetic energy. But total energy always at every point of fall remains constant. What an interesting reality! Let's try to figure this concept out with the help of example and simple mathematics. Always keep in mind that total energy is the sum of all possible kinds of energy, but if we talk about free fall in an ideal system. Always keep in mind that total energy is the sum of all possible kinds of energy, but if we talk about free fall in an ideal system, then this total energy is the sum of kinetic and potential energy. Consider a body of mass m at rest at a height h above the surface of Earth, as you can see here. We will try to find energies and total energy on three different positions A, B and C. At position A, the body has potential energy mgh, whereas kinetic energy is 0 because the body is at rest. Here total energy will become mgh. Let's release the body and see what happens. We can examine the body that has started losing its height and gaining its motion. Let us calculate potential energy and kinetic energy at position B when the body has fallen through a distance x, ignoring air friction. At position B, the remaining height of the body from the ground will become h minus x. Thus, the body will have potential energy equal to mg h minus x and kinetic energy equals to half mvb square, where vb is the assumed velocity of the falling body at position B. And we can find it out using the third equation of motion. I am leaving a question for you viewers here to know your understanding. The question is, why we use the equation of motion here to find out velocity? Answer this question in the comment box. Now back to our topic. As the body started its motion from rest, so initial velocity will be considered 0. The distance it covered is x, and acceleration is the acceleration due to gravity toward the downward direction, so we will put positive g. The final velocity is the velocity at position B is assumed Vb. So putting all the values and applying mathematics, we will get the result Vb square is equal to 2gx. So putting this result into this equation of kinetic energy at position B, then we will get the result as kinetic energy is equal to mgx. The total energy at position B will become, putting the value of potential energy from here and kinetic energy mgx, the result that we will get so cancelling out this positive mgx with this negative mgx, we will get the result of total energy as mgh. Let's allow the body to complete its trip and hit the ground. At position C, just before the body strikes the earth, potential energy is 0, as height has become 0 from the ground, and kinetic energy is equal to half mvc square, where vc can be found out by the third equation of motion, as we have calculated the value of vb earlier. All the parameters we discussed for finding vb will remain the same for vc instead of distance s. Now the distance is actually the total height covered by the body. Now putting values in the third equation of motion, we will get vc square is equal to 2gh. After putting it in equation, we will get kinetic energy mgh. So I am going to put this vc square here in this equation. Here again, total energy will remain mgh. As you can see here, the value of potential energy at point C is 0 and kinetic energy mgh H. The total energy will become mg and H. Hence, we proved the law of conservation of energy as well as the interconversion of kinetic and potential energy. Actually, when a body falls, its velocity increases, meaning the body is being accelerated under the action of gravity. The increase in velocity results in an increase in its kinetic energy. On the other hand, as the body falls, its height decreases and potential energy also decreases. Thus, we see that loss in potential energy is equal to gain in kinetic energy, where v1 and v2 are velocities of body at height h1 and h2 respectively. This result is true in an ideal system, meaning when there is no frictional forces. If we assume that a frictional force F is present during the downward motion, then a part of potential energy is used in doing work against friction equal to Fh. Thus, the remaining potential energy, which is equal to mgh minus Fh, is converted into kinetic energy. So, the final result will become mgh is equal to half mv square plus Fh, where mgh is the loss in potential energy, half mv square is the gain in kinetic energy, and Fh is the work done against friction. This was our today's lecture, and hope you liked this video and learned something new. If so, then like this video and share it with others. Do not forget to subscribe to the channel and hit the bell icon to watch all new videos. Now we will meet in the next video. Take care of yourself. Allah Hafiz.